Okay, good afternoon, everyone. I hope you had a good Thanksgiving break and you are ready for the last 2 weeks of class. And in the last 2 weeks, we're going to learn a lot because we have to. I had to miss some lectures, so we have to learn a lot the last week of class. And what we're going to learn is absolutely important for you. So we're going to start chapter 4. But before chapter 4, so basically today, the main idea will be chapter 4 or section 4, which is the logarithm. All right, but before I do that, I need to back up a little bit and I need to talk about the exponential function. So this, the exponential function. F of x equal e to the x. Okay. All right. So first, let us remember what's an exponential function. Exponential functions are functions that has the form, so that's what they are. Exponential function, usually they are functions that have the form a times b to the x. That's what an exponential function is. Okay, and b, what we call the growth factor. So we took lots of examples of those. So I can take f of x equal a times 1.2 to the x. The b here is 1.2, which is bigger than 1. It means we have an increasing function. I can take f of x to be a times whatever, 0.97 to the power x. My b is 0.97. It's less than 1. That's a decreasing exponential. Now, there is a base, which is extremely important. And everyone who study calculus will realize that's going to be the base that they will be working with. And the base is E. The base, I mean the B, the growth factor. So what is E? E is a number. I'm sure a lot of you probably have heard of it. E is a number. It's just like pi. It's just a number. And its value is almost 2.7182. So, and etc. Okay, so you can find on your calculator. So E is a number, and the function f of x equal e to the x become an exponential function where the base is e. So e is not a variable, it's just a number, and f of x equal e to the x is sometimes people call it the exponential. So that when I say the exponential function, they use the word the, it means it's f of x where b is e to the x. So let us graph it a little bit just because of its importance. So we're going to graph it. And to graph it, I'm going to pick up some values just to make you comfortable with the e as a number. So I'm going to pick -2, -1, 0, 1, and 2. So this is e to the x. So what is f of 0? Is e to the 0. Anything to the power 0 is equal to 1. So graphically, that's f of 0 is 1. That's what it is. What is f of 1? Remember, f of 1 is a number. F of 1 is e to the power 1, which is almost 2.7182. So at 1, the function takes, okay, actually, let me make this one, and this is 2. So the function takes the value e, which is 2.7. At 2, what is f of 2? It's e squared. So the only thing I'm emphasizing that e is in numbers. That's what I want you really to be careful. So that's 2.7182. And our calculator compute those. So basically the calculator, if it's on, it does compute e to the power 2. It's 7.38 now. It's just really a number. 389. So at 2, the function is right there. I mean, it's really, really rising because this is 7. So the function is that's typical exponential function, which is really increasing. Now for the negative value, f at -1 is e to the -1. Remember, e is a number. It means 1 over e. It means 1 over 2.7182. Okay, I'm writing it this way just to remind you that it's really actually a number. And then we can pull this a little bit up. That's going to give me, so if I take e to the, your calculator actually compute that. So it's a number 0.367. So if I have -1, my values become right here. And if I take -2, I'm getting even a smaller number. It's e to the -2. It means 1 over e squared. It means 1 over 7.389. So the number is less than the one before it. So it's going to be down here. And if I take -3, I'm going to have even a smaller and a smaller number. And if I connect them, that's the function f of x equal e to the x. So e is a number. It's absolutely crucial if you study calculus. It's really one of the most important number in calculus because the formulas of calculus become fairly easy if we use e as the base of the exponential function.
Do you always use the 2.7182 out that far, or do you do it like pi, like 3.14?
E is 2.718.
Okay.
That's its value.
Right.
Like pi is 3.14, blah, blah, blah.
Right.
E is that number. It's,
okay, so you go out to like the 4th, 5th digit. Okay.
Right. And your calculator takes more. So if you plug it into your calculator, it has the E button in it.
Okay.
Okay. So for example, watch I'm entering it. E. That's the E. And then any E square, 7.3890.
Okay.
If you guys have a calculator, pull it and make sure you can locate the E. It's such an important function for you. All right, to answer your question?
Right. Yes.
Yeah, crucial. What I care about, it's a number, because shouldn't think it's an EU, it's a variable. No, it's not a variable. It's just a number. Here, x is the variable, not E. E is just a simple number, which is important. That's as simple as that. Very good. So this takes care of the E. Now we're going to start studying the logarithmic function, which is a little bit hard, not fairly easy, but we will hopefully will get through it. So first, what is the goal of what we're going to do? So the goal of this chapter is actually to learn how to solve equations of the following form. So we've seen a lot of basically real life problems where the function is given by this formula. So for example, if I have like a bacteria, its starting value is 20. And it grows by 50% per day, let us say. Okay, so every day it's an extra 50%. So in this case, that's an exponential growth. Then the formula would be, that's the growth rate, 0.5. It means the growth factor is 1.5 to the power t. So that will be the bacteria population. And suppose, so that's it. That's my scenario. So that's the population is growing. And let us say, I say, all right, when will the population, for example, suppose I want to know when the population is actually 22, increase a little bit. So I want the population to be 22. And the question is, what is the t that makes the population 22? Okay, so it's not any trivial, it's not an easy question, because what I am asking for now, my unknown, is the exponent. I'm really looking for the t that caused this to be equal to 22. So it's not a trivial problem anymore. Okay, so the goal is actually to learn how to solve equation of this form where the unknown t is an exponent. That's it right there. It's right there. So it's not 2t plus 1. It's not something as simple as 2t plus 1. equal to 22, where I can isolate my t. This is not really easy here because my unknown is it. Okay, so that's really the goal. But to be able to do that, to be able to solve this problem, what we're going to need is to introduce a new function, a new rule. And we're going to call it the logarithmic function. So to be able, we have really to introduce something new, a new function that we're going to call it the logarithmic function. And we're going to start defining it. What is this logarithmic function is? Okay. So, all right. First I define, and then we work with it. We're going to work a lot with it today. So, definition. Suppose n is a positive number. And later on, we say why we need it positive. Then the log of n, that denoted by log, log of n. So I'm really talking about a new function that I'm going to give it an input, and this function is going to give me an output. And this function, we're going to call it the log function. And how is it defined? So denoted by log n is defined as follows. So at first, the definition is bizarre, but it won't be bizarre for log. The log of n, if you have any integer n, any number n which is positive, the log of it, means the output that I'm looking for, is the exponent of 10. It means what I should put here that gives n. So the log of n is going to be the power. So that's going to be definition. So the output is the power of 10 that gives n. Now, why 10? Because it's a nice number. That's a nice number. And then we're going to do it with the number e. But that's a nice number. That's a base that's used a lot. So the log of n is the power of 10 that gives n. So let me elaborate a little bit. What's the log of n? The log of n is the box. I'm going to is the number that I'm calling it the box that has the property 10 to this box equal to 10. So log of n is the box, what should go here, such that 10 to this box equal to n. That's the log of n, this box here. Okay. So in short, log of n is equal to the box, means that 10 to this power equal to n. So the log is exactly what should go here, which give me n back. Okay, so that's the definition, and that's what we're going to be working with right now. So that's really what the log of n is. So before I start asking you lots of questions, let me at least give you one example, and then it will be, we're going to be working together. So example, what does it mean to find the log of 100? So my n here is 100. That's my input. What does it mean? It means we need to find the power of 10. To which power? I should raise 10 to get 100. So the log of 100 is going to be a number. What's this number? It's the power of 10 that gives me 100. But now what do we know? We know that which power of 10 give me 100? We know that 10 squared is equal to 100, which means that the log of 100 is equal to 2. So the log of 100 is to which power I should raise 10 to get 100. So that's the log. It's the power itself that's going to give me a 2. Okay, so with this in mind, this definition in mind, we're going to kind of try to learn, try to play a little bit with this definition. Okay, and now I'm going to ask you the following, and you guys are going to help me with the answer. So the log of n, that's really, so the log of something is the number, such that when I take 10 to the number, I get n back. So the log is the power itself. So let me ask you several questions, and I want all of you to help me with the answer. The question is, find each of the following. No calculator at all inside for now. Find each of the following. All right, I don't want a calculator because the calculator has the log button and you guys can figure out everything, but you will miss the meaning of what we're looking for. So my first question is, what is the log of 1? What is the log of 1? Means n here is 1. So what is the log of that? It's the power. So looking for it, it means I'm looking for the power of 10 that will give me 1. Okay, that's really what it means. I'm seeing a lot. So what's the log of 1? It's absolutely equal to 0 because the power here is equal to 0. Okay, so that's really this. Now I'm going to ask a lot of questions since you guys are picking up. What's the log of 10? Again, this is my n. What's the log of n? It means what's the power of 10 that gives me 10? 1. Agree? Absolutely 1. Okay, now we keep going. What is the log of 1 over 10? What's the log of 1 over 10? Again, it means 10 to which power will give me 1 over 10. We're just practicing the definition. We're trying to practice definition. Minus 1, absolutely, because 1 over 10 is 10 to the minus 1. So the log of 1 over 10 is exactly minus 1. That's the log. This power here, I'll put it in red, this power is what the log is. Okay, 3 more along those lines, I guess. 3 more because you guys are doing fine. What's the log of, I know, square root of 10? Again, what does it mean? What's the log? That's my n. What's the log? The log is the power. That's what the log is. It's the power which gives me the square root of 10. Okay? All right, now we remember what's the square root is? It's 10 to the power a half. So what's the power of 10? That's equal a half. Okay, so we're just practicing the definition. We're now in the process of practicing the definition. Okay, one more. What's the log of, okay, I'm using this to remind you, basically, what's the log of 1 over the cubic root of 10? Remember what's the log is? This is the power that give me 1 over the cubic root of 10. Okay, all right, anybody else? Anybody? Ask yourself, try to remember. Yeah, because let's see, what's cubic root of 10? It's 10 to the 1/3, which is 10 to the minus 1/3. So the power is minus 1/3. Okay, so that's the log. It's a very, very bizarre definition. I mean, the log is the power, which is not really a trivial idea. Now, my last question is, when I defined the log, I said, let n be a positive number. That's how I defined it. And now we're going to figure out why we need what goes inside to be positive. So suppose I ask you the following question. What's the log of minus 1? What's the log of minus 1? It means, so the log is the power. It means 10 to which power will give me minus 1. Is there a power of 10 that spits out negative 1? What can you say? Try to think. Let's remember, how does the function 10 to the x looks like? Suppose I'm going to graph the function this function. The input is x, the output is 10 to the x. Okay, how does the graph looks like? Let us think about it. I don't know, anybody can say anything before I pitch in. Can anybody give me a power of 10 that spits out a negative number? And the answer is an absolute no. Why is no? Suppose here I have positive, like 10 squared. 10 to the power, let us really analyze it a little bit. Analyze it. 10 squared is definitely positive. 10 to the power a half is definitely positive. And even if I take a negative power, 10 to the minus 2, can this be a negative number? No. Even if this is negative, 10 to the negative 2 is 1 over 100, which is a positive number. 10 to the negative minus 5 is 1 over 10 to the power 5, which is also a positive number. So 10 to any power is positive. And the graph 10 to the x goes like this. It's always a positive function. So no, because, now I explain, no, because 10 to any power is a positive number. So we cannot have log of minus 1, because log of minus 1 is the power of 10 that gives me minus 1. No power of 10 give me a negative number. All the power of 10 give me positive number. That's why the log of, if the log of something, the something inside the log has to be a positive number. So that's really the idea. Okay. Now, again, I'm going to keep going with the definition and the same type of questions, relatively. Try to understand this definition a little bit more. So my question now is the following. So let us recall one thing about the log. So log of 10, let's remember, log of n equal to a box means that if I take 10, and later on I will not write box anymore, I get 10. So the log is this power. So now my question is going to be the following. Rewrite each expression, each equation using exponent. And of course, I'm going to explain what I mean by that. Exponent. All right, what do I mean by this? I mean the following. Suppose I pick up my calculator, okay? I pick it up. And there is a log button on my calculator. So I push the log button on this calculator, okay? And let me say I compute log 50. And I push this and I get an answer. All right, so I get, this is from the calculator. I get an answer, 1.17609. I'm gonna stop right there. What does this mean? What does this mean? I mean, what is it? What this 1.7 blah, blah, blah means to us? I'm going to rewrite using exponent. What does this mean? Means that I take 10 and I raise it to the power 1 point that I should get 50. Okay, it's the power of 10. Exactly. It's the power of 10 that gives me 15. That's really, so when you push those buttons on your calculator and you get log 15 equal blah, 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 what does this mean? It means that this is the power of 10 that gives me 15. And that's what I mean by rewrite using exponents. The idea is to try to understand it a little bit. So let me take another one. Again, I suppose I pick up my calculator and I play with it and I compute the log of 200 and I get 2.3. Wow. And I'm just gonna take 2 more digits. What does this mean? Again, what does this mean? It means if I take 10 and I raise it to the power 2.301, this will give me 200. Okay, actually I can do that. If I take 10 and I raise it to the power 2.301. Okay, I'm getting, of course, because I'm doing rounding, 199.98. So that's really what the log represents. It's this power here. It's this exponent. So that's now I'm going to do it a little bit. Suppose I tell you log of t equal to 4. I want you to write this using the same idea, using the idea of exponent. It means what? Use the same idea. So basically, I'm going to tell you find t in a way. So what does it mean? Log of t is equal to 4. And the question really is find t in this problem. Think in terms of exponential. It means 10 to which power equal what? Who can figure out? Who can fill up the boxes for me? The log is the power of 10 that gives me the insight. So this means that if I take, this means that if I take 10 to the power 4, this is equal to t. So log t equal to 4, it means the log of t is the power of 10 that gives me t. It means 10 to the power 4 is equal to t. Okay, so the input output basically kind of change in a way. So in general, so let me write this anymore. I'm going to write 2 in. So in general, if I tell you log t is equal to y, it means if I take 10 and I raise it to the power y, I get the t back. Okay, that's the general idea. Now, another important fact before I move on. Suppose I have n positive, of course. And this is going to confuse you a tiny bit, but that's okay. Suppose I take 10 and I raise it to the power 10. Sorry. No, I'm right. What should I get? For you answer this question, let us play the following game. Suppose I take 10 to the power log of 15. What this will give me? What this should give me? Let us remember. What's the log of 15? The definition. It's the power of 10. That's what log 15 is. So when I computed log 15, I get that. What does the log of 15 mean? It's the power of 10, which will give me 15. That's really what the log is. So the log of 15 is a number. What's the number mean? What's this number? It's the power of 10 that gives me 15. So if I take 10 to the power of log of 200, what does this give me? What's the definition of the log? So this number here is actually the power of 10, which will give me 200. So that's really the definition. There is nothing really more to that. So 10 to the power log of n is actually gives you n back. So 10 to the log 15 gives you 15. 10 to the log 200 equal to 100. And this is by definition of the log. That's really how the log is defined. Okay, so the log is of it's something is the power of 10, which will give you this number n itself. So log 10 to the log 15, 15. I mean, if you plug it into your calculator, basically, that's what I'm telling you. If you take 10 and we raise it to the power log of 15, I get 15. Because that's the definition of the log of 15. It's the power of 10 that should give me 15. And I can keep doing this over and over and over. Okay? So the log of n is the power of 10, which is going to give me n. Now I'm going to define another logarithm by the same idea, but I'm going to change the base 10. So part 2 is what we're going to call the natural logarithm. So I did the definition, and then we played the same game we played before. What is the natural logarithm? It's, as I said, it's almost the same definition. I'm changing very little. Natural logarithm. Let n be a positive number. Then the natural logarithm. So I'm adding a word, not the regular logarithm of n. The natural logarithm of n, or simply ln of n, is defined as follows. ln of n is the exponent of e that gives n. So immediately I contrast with the following one. Log of n, when I have log, is the power of 10 that gives me n back. ln of n is the power of e that gives me n back. So it's really almost the same definition, but here we use 10 as a base, and here we use e as a base. So ln of n is the power of e that gives me n back. So ln of n is the number, the box, that has the following property. So it's the box that has the following property. E to the box is equal to n. So in short, that what's ln of a number is the box. Which property have this box? E to the box is equal to n. That's really what it means. So let us do the same thing we did a minute ago, but now I'm going to use ln instead of using log. So again, more practice. Find the following. Okay. First is, okay, I'm going to skip the first. I'm going to go immediately here. What is ln of e? So let us remember the definition. ln of e is the something. What's the something? It's the power of e that gives me e. Now I want you to start interacting with me. So ln of e is the power of e that gives me e. E is a number. Don't be afraid of it. So which power of e gives me e? Of course, is 1. So ln of e is equal to 1. When I use the log, watch what I have. Log of 10 equal to 1, because here I'm looking for the power of 10 that gives me 10. Now, ln of e is 1, because here, when I put ln, I'm looking for the power of e that gives me e, which is equal to 1. So that's really the difference between them. Okay. Now, what is ln of 1? Again, it's the same definition, but now it's the power of e that gives me 1. And now I think all of you should be able to answer those questions. So ln of 1 is what I should put here to get 1. So what shall I put here? Quickly, I want answers right now. 0. Anybody else? Yeah. ln of 1 is 0, because that's the power here. Okay, let's do a lot more. What is ln of e squared? Okay, what's ln of e squared? It means what's the power of e that gives me e squared, which is basically spit out. So what's ln of e squared? Quickly. Absolutely 2, because ln of e squared is what should I put here to get e squared? Okay, you put 2 to get e squared. Okay, now what's ln of 1 over e? Remember, e is a number. Don't be scared from it. Again, it's ln of e is this power here. What should I put here? What should I put here to get 1 over e? Quickly. Minus 1, because this is e to the minus 1, so that's equal to minus 1. So we're repeating the same idea, but this time with a different the exponent. I'm looking for the exponent of e, not the exponent of 10. So let me give you one more. What's ln of 1 over e to the 5? Practically the same ideas. E to which power will give me 1 over e to the 5? Go ahead. We have a lot to learn, so you guys have to help me by answering. E to the minus 5. So the power here has to be minus 5. And so on and so forth. So I can keep giving you the same type of questions. Now, again, what's of ln of minus 2? Is this defined? It means which power of e gives you minus 2? This is none, because e to any power is a positive number. So if I put a negative 2 inside the log, this is again not defined. Okay. So whenever you have the ln or the log, what should go inside here or here, those has to be positive number, because e to any power is positive. There is no way I can bring in a negative number when I take e to a power. All right, now again, I'm going to do like last time, ask the following type of questions till we kind of a little bit interact with that. I want to ask you those. Rewrite each equation using exponent. Okay. And this based on the definition. So ln of n equal to a box means if I take e to this box, I get n. That's really what we are looking for. So again, suppose I pick up my calculator and I evaluate ln of 15. Now we have to be very careful not confuse log with the ln. So the calculator have the ln button on it. That's the ln. ln of 15 is not the same thing as log of 15, because it's log of 15 is the power of 10. ln of 15 is the power of e. So if I pick up my calculator, I get 2.708. And what does this mean to you? What it means to you, it is really a bizarre thing. It means that if we take e to the power, to this power, this will give you 15, because that's really what the definition of the log, e to the power log of 15, sorry, ln of 15, that's really what gives you 15. That's the definition of it. So again, we're going to use another one. What is log ln of 200? So ln of 200 is, according to my calculator, is 5.298. Means if I take e to the power that, I should get 200. That's the log. That's the log. That's what it is. So this number here is the ln of 200. So now suppose you tell you that ln of t equal to 4. Find t. By rewriting as using exponent. So what is ln of t? A little bit more abstract. What is ln of t equal to 4 mean? Mean that e can anybody fill the details? So ln of t, what is ln? ln is the power, right? So I can see 4 and t. It means e to the 4, that's the ln of t, that's the ln. is equal to t. That's really the relationship between them. So as you realize, the input of the ln, if you want, becomes the output of the exponential. The output of the ln is the input of the exponential, kind of the reverse. So it means t is, no, it's t is e to the 4. Okay, so ln of t equal 4, it means t is e to the 4. All right, so now the property that I mentioned for the log, I need it here for the ln. Right. And that's very important. So suppose n is a positive number. If I take e, the number e, and I raise it to the power ln of n, what should I get? So before we answer, let's see what I'm talking about. Suppose I take e to the ln of 2. What should I get? E to the ln of 4. What should I get? E to the ln of 6. I'm going to first use the calculator to compute them, and then I'm going to explain it. So if I use my calculator, e to the power ln of 2. My calculator gives me a 2. Am I surprised that it gives me a 2? Am I surprised? What do you think? Should I expect 2 or I am surprised? Anybody? Not surprised. Why? Because that's the definition. That's what ln of 2 is. That's what ln of 2 is. What should I raise e to get 2? This is a bit hard, but that's really what it is. That's it. What's ln of 4? This is 4 because that's what the ln of 4 is. It's this bizarre number that has this property. And there's only a calculator to compute them. I don't know how to compute those. What's ln of 6? It means what's the power of e that gives me 6? That's 6. Finding ln of 4 and ln of 2 is a very hard thing. I mean, without a calculator, we cannot do it. So in general, the ln of n will give you n back. Very important relationship between them. All right. So now let me summarize some of the properties of the log, and then we're going to see more property, which is going to help us actually to work on our main goal of today. So let me summarize some properties. And every time I'm going to summarize, I'm going to put them for the ln and for the natural log. So some of this summary. The first step, it should be a straight line. It's not. Okay. So some of the summaries. Okay. First, I draw a line, imaginary line, and everything I'm going to put is for the natural log and for the ln and for the log. First, log of 1 is 0 for both of them. Okay, 2. Those are things we should know. Log of 10 is 1. ln of e is 1. We have to be very careful between them. 3. Log of n makes sense only for n positive. And the same here. ln of n makes sense for n positive. Okay. Now, there are the 2 very important properties. This one is that if I take 10 and I raise it to the ln of n, I should get n back. Here, if I take e and I raise it to ln of n, this should give me n back. This is the definition. That's what the definition is really about. What's ln of something? It's the power of e that gives me the n. The last one that I didn't talk about, but it's actually easy. If I take, and I will ask you what it is, log of 10 to the power, I don't know what I'm going to, little n is equal to what? And ln of, actually let me put x here, and ln of e to the x should give me what? Okay, I didn't talk about it because it's not hard. Let me see if you guys can guess it. What's log of 10 to the x? What should I get here? Use the definition and the answer will be clear. Use the definition. This, the expected value is absolutely x. Why? Because what's the log of 10 to the x? It's what power of 10 will give me 10 to the x. Okay, that's x itself. And the same thing here. This is equal to x. Why? Because what's ln of e to the x? What's ln of e to the x? It's the power of e that should give me e to the x. That's what the ln is. The power of e will give me x back. So these are summary of the properties we've talked about. Okay. Now the logarithm has a lot of other properties that are extremely useful. So those properties, we all got them from the definitions. And the main link, before I move on to the other properties, the main link is the following. So here I keep rewrite them. So log of n equal to y means that 10 to the y equal to n. Previously, I used box. You can keep using boxes. ln of n equal y. It means that if I take e, I raise it to the y, to the ln, I get n back. So this is the relationship between them. Okay. Now, we're gonna move to another set of properties that I will not explain them, but I will just give them to you. We don't have time to get deeper into them, but they are extremely useful. Confusing at first, but extremely useful. And those are the properties that are going to help us to solve the problem we started with. So the logarithm, okay, has other properties that are extremely important. So the logarithm has another set of properties that are extremely useful. And we're going to write them. Extremely useful. Okay, and now here they are. I'm going to write them on this piece of paper and I'm going to refer to them all the time. And I will write them for the ln and I will write them for the log. So these are the properties here. Suppose a and b are positive numbers. Okay, then here we are. Log, and I take those numbers and I multiply them by each other. So that's the first property. I'm going to call it 1. Then the log of a times b, what the log will do is to transform this product, into a sum plus the log of b. Okay, so the log of a times b is the log of a plus the log of b. So 2, and then I will work into every one of them. 2 is, if I take the log of a number a, and I raise it to a power. And that's going to be one of the most extremely important properties. What the log will do is the following. You take n, bring it down, times the log of a. Now, everything I say about the log, I can say it about the natural log. It means that if I have ln of a times B. This is ln of A plus ln of B. ln of A to the n, it's n times ln of A. Okay, so this power will be brought down. And the third property, and then we're going to talk a lot about those, so you can, tells me that if you take log of A over B, so if you divide two numbers, you get the log of A minus the log of B. Annoying properties to say the least, but they are important. So it's ln of A minus the ln of B. Okay, so these are the properties of the log. And let's work with them. Let's work with them a little bit. So let's work with the first one. Okay, let's work with the first one. Okay. Suppose, what does the first one tell me? Let's do some practice problem. Analyze the first one. The first one tells me the following. If I have two numbers, A and B, then the log of their product is the sum of the log. So for example, you don't have to write this, but I want you to give you a feeling for that. Suppose I tell you the following. Log of 2 is, I pick my calculator, 0.301. And suppose I tell you the log of 3 is 0.477. All right? And I'm giving you those, and I'm telling you, quote unquote, assume your calculator is broken. Okay, for a little bit. Okay, and my question is, can I find the log of 6? Okay, so now I'm giving you those two numbers, and I'm going to assume my calculator is broken, and I'm asking you to find the log of 6. Now, when I learned the log, which is in the Stone Ages, as far as you guys are concerned, where we did not have a calculator, that's how we work with the log. So they will give us two numbers, then they tell us find the log of that. Now, how are we going to do that? Okay, I say, all right, 6 is 2 times 3. Okay, so the property of the log tells me if you have a multiplication in here, this will become the log of 2. That's what I'm applying, plus the log of 3. That's what this property tells me. So it's turning this product into the sum. Now, why is this helpful? So if I know the log of 2 and I know the log of 3, now I can add them and get the log of 6. So it's going to give me an 8, it's going to give me a 7, and a 7, 0.778. So now if I go back to my calculator, that I'm not going to assume it's broken anymore, and I compute the log of 6, I'm getting exactly 0.778. So that's how we're going to use this property. Of course, not to compute the log 6, but just to make it a little bit real for you. All right, with the same token, suppose I'm going to apply the second property using the same problem. Again, I'm going to assume my calculator is broken. And I'm going to ask you to compute the log of 8. To compute the log of 8 using the second property. So I want you to compute that using this property. Who will have any idea how to do it? Okay. Who can relate this to that? I'll start helping you. Log 8 is 2 to the power 3. So what does this property tells me? Tells me the following. If you take a to a power n, it's n times log a. So this property tells me if this is your power 3, tells me that the log has the property that you can bring the power down times the log of 2. That's what this property is telling me. So this is here, my n is equal to 3. So that's the 3 times the log of 2. So if I know the log of 2, I can multiply by that and I get the log of 3. So which is I multiplied, it's going to give me 0.903. And now if I use my calculator and I compute the log of 8, I would get exactly 0.903, which is what we get right there. Okay, so that's how those properties are used. So if you have the product, log of the product is sum of the log. Log of 2 to a power, you can take this power and bring it down times the log of 2, and then you get the 0.903. Right, now we're going to do another problem, not like that, a little bit different, and to help us practice those properties before we use them to solve equations. So right now, I just want to practice those properties. So this is the problem I'm going to put in front of us, and you guys will help me out. And these are the properties. Never lose track of them. So you're given the following. Okay. Two numbers. I told you that the log of A is a certain number P. And the log of B is a certain number Q. Right? My question to you is, express the following. Express the following in terms of P and Q. I do the first problem, you will be having to do the second problem. So the first problem is, I want you to express, so the goal of this is to practice the property. Log of A times B, and I want you to express this in terms of P and Q using all the properties that the log have. That's really the properties you want to use. So what does the property of the log tells me? Log of the product is the log of A plus the log of B. Okay, we will not make up any rule. We just use the rules given. Now, log of A is P, log of B is Q. That's P plus Q. Now I'm going to give you another one, and I want you to be able to give me the answer. So I want you to find log of A to the power 4 in terms of P, using the properties. This, or that. All right, you have 2 minutes to do this problem. Actually, 1 minute to do this problem. And these are the properties. 1 minute and put it on the chat so we can practice those properties a lot. Okay, I don't see anything. I don't see anything on the chat. I don't see anything on the chat. I'm starting to see something. Okay. All right. Anybody else? Anybody else? All right. I will do that to help you out. So log of A to the power 4. I'm going to use the second properties right there, where it's going to play the role of 4n. So this property tells me log of A to the 4 equal to, this is the power that will go down times the log of A. It's n times the log of A. Now what's the log of A? according to what I told you, the log of A is P, so this is 4P. Okay, that's what it is. That's the log of A. The log of A is, I give it a letter name, called it P, so this is 4P. Okay, another question. I want you to do the following. Log of A2 times B. I want you to express this in terms of P and Q. I keep all the properties in front of us so you never lose track of them. And please, I want all of you to do it. All of you. I'm reading the chat, so I know who's participating. Okay. All right. And when we're going to do them, we're going to write them clearly to see which property I'm using every time. Okay, I'm getting good answers. All right, so let us see how we're going to do that. First, I have a product. The property of the log, the first property tells me if you have a product, then this could be written as the log of A squared plus the log of B. I'm using property 1. That's crucial to know. Okay? It's a plus. The product turned into plus. That's crucial. Okay, now, what's log of A squared? Here, I have a power, 2. The property of the log tells me if you have a power, you can bring it down. 2 times log A. That's the second property, plus the log of B. Okay, now I have every piece. This is going to give me 2P plus Q. Be very careful. The product turned log of the first plus log of the second. It's not log of the first times the log of the second. The here is turned into a plus. I know that are not easy, but we have to internalize them. All right, now I'm going to give you more. Now, whether I give you the ln or the log, they actually act the same. So it doesn't really matter which one we use to practice. So now let me give you log of A over B squared. And this is what I want. And these are the property of the log in front of you. Please, each one of you do it. That's how you know whether you're getting it right or wrong. And I want you to write it like I'm trying to do it. Just break it apart so you can work it and make sure you're using the correct property when you're breaking it apart. Okay? I want more students. I mean, I know you guys can read the chat, but okay. So I'm getting something correct. All right, let me fix it. Not all of you. I have some wrong. I have some wrong answers. So let's do that. I have A over something. The last property tells me that this becomes the log of A of the numerator minus the log of the denominator. So that's the property number 1. So this is going to be log of the numerator minus the log of the denominator. Okay, that's using the third property of the log. But now, what is this? That's the log of A. I know that log of A is P, but I don't know what's the log of B to the power 2. So that's the log of A minus. Now, what is log of any number to a power? What the log will do to it, it means it takes the power and brings it down. It brings it down. It doesn't raise it to the power n. It brings it down. So it means that this 2 here is going to be brought down, and then this is 2 multiplied by the log of B. Okay, watch carefully how this is working. So which is going to give me basically log A minus 2 log B, which is, I called it P minus 2Q. So it is the log of A minus 2 times the log of B. Where the 2 come from, the 2 is this power of B squared. Okay, more till everybody feel comfortable. So actually 2 more. Suppose I give you the log of B times the square root of A. I'm listening, I'm reading. Oh, sorry, these are the properties. These are the rules that you can use, nothing else. You don't make up your own rule. These are the rule that you use. Okay, I have one answer so far. It was sent privately. I want other answers. Even if you put wrong answer, I don't really care. Just put what you got, because that's when I see wrong answer, I can point out the mistakes that already I see some. Anyone? Okay, let's see what we see first. We see a term multiplied. Okay, so it means something multiplied by something. What the log will do to it, it just turned it into a sum. So let's see how it's going to turn it into a sum. So it's the log of B plus the log of the square root of A. Okay? Now, the log of B, I know it. So this is a P. Square root of A, I don't really know it. It's kind of problematic, but we can deal with it. What's the square root of A? You know, math really like exponent, fractional exponent. It's A to the power a half. Okay, so the square root of A is A to the power a half. So now I'm going to make use of that. I'm going to write this as the log of B plus the log of the square root of A is not A squared, is A to the power a half. Okay, I keep working till I can get log A by itself. So that's the log of B plus a half here is my power. And that's the half that will go down. This is one of the tools that we're going to use the most next time. So that's a half times the log of A. So we have to be very careful with the power. Now finally, I'm going to get, this is a Q, and this is a half times P. Okay, so that's really what we have to be careful with. The square root of A is A to the power a half. When I bring it, it becomes a half times the log of A. Okay. One more, and then I will talk a little bit about what properties fail for the log, and we give example. But let me give you one more along those lines. Again, the same type of question. Suppose I add like 100 times A to the power 3 times B to the 5. Okay, so basically I'm multiplying 3 things by each other. Okay, give it your best shot. Okay, anybody? You're not using the property correctly. Every time you use them, put them in front of you. Put them in front of you. Okay? And the log turn the product into what? Be careful. Multiplication is becoming a sum. Multiplication is becoming a sum. Be very careful. Multiplication is becoming a sum. So this is going to be log of 100 plus the log of a to the 3 plus the log of b to the power 5 was equal to. Okay, I skipped it for a reason. Now, log of a to the power 3, that's the power which will go down for us. That's my 3 times the log of a plus the 5 log of b. Okay, and this is log of 100, you're right. But what's the value of log of 100? Who can tell me what's log of 100 equal to? Because that's easy, that's why I picked 100. What's the log of 100? Never forget the meaning. It means which power of 2 give me 100. That's what the log of 100. So log of 100 is actually equal to 2. So that will give me a 2 plus 3p plus 5q. Okay, so the goal of those problems is really to practice the properties of the log. Very carefully. Now, which properties fail that, you know, we want them to use them, but they fail. So what fail for log? That's important. And I give you examples for that. And whether I use log or the natural log, they are actually have the same properties. So first, the most important one that it's very natural for us to do this mistake, but doesn't work. If I have a sum in here, watch carefully. If I have a sum, this is not, I cannot break the sum. This is not that. Sum cannot be broken. Okay, so if I have log of the sum, it stays log of the sum. There is no way I can break up the log of the sum. Be very careful. What I can break up is the log of a plus the log of b is the log of the product of the numbers, not the sum. So I cannot break up the sum, and we can actually take examples. I mean, the only way I can show you that, I can give you a bunch for examples. So let us say, and basically using our calculator. So suppose I take a to be 2 and b to be 3. Then the log of a plus b is the log of 5, which is basically the power of 10 that gives me 5. And since I don't know what it is because it's hard, it means the power of 10, let's give me 0.698. However, when I break it, when I take ln of A plus, sorry, the log of B, it means log of 2 plus the log of 3. When I break it, I get something totally different. So if I take the log of 2, I add to it the log of 3, I get 0.7781. Absolutely different from each other. So we cannot break. We have to be very careful. If you have log of A plus B, it stays log of A plus B. You can't break the sum. We can break only the product. Be very careful. Don't make up rules. Just stick to the rules that we are learning. A second mistake that student tends to do is the following. Okay, which is natural. I mean, I'm not blaming the student because, you know, you don't know where those properties are from. The property tells me the log of A, B is the log of A minus the log of B. This is true. Okay, that's the true property. What you can't do, what's wrong, is what our intuition will tell us. And it's not the log of A over the log of B. That's not, we cannot break the log. This is absolutely wrong. We can again do the same type of examples. So what I have is log of the quantity A over B is the log of the numerator minus the log of the, that's the true. This is absolutely false. So when we're using the property of the log, please just take those properties, and these are the ones that you can use. Try not to invent properties of your own. Okay. All right, at this note, I finished today. So please do your homework. It will not be online because there is no more online homework. There will be practice from the book. So please do them. And you are going to have a short quiz next Thursday. Just cover those ideas that we're talking about. Right? Any questions before I let you go? Okay, have a see you next Thursday then. Bye-bye, guys.